We're now going to introduce the idea of divisibility. And so let's get started with that. So suppose that R is a commutative ring. And we have two elements of R. Well, just like with the integers, we're going to say that A divides B if there exists some C in R such that B is equal to AC. Now, this doesn't need a domain in our definition, but we do need commutative. That way we don't have to distinguish between left divides and right divides. So commutative is necessary. When this happens, we say that A is, and also C in this picture, is a factor of B, just like in the integers. And we're going to see that divisibility is particularly suited to domains. Okay, and later in this chapter, we're going to look at a particular domain, or in this section rather. We're going to look at the polynomial ring over a field, and we're going to see a lot of the same thing that happened with the integers happen with that domain. So, this is our definition, and let's do an example. So let's find all the factors of 2 in Z5, and then we're going to find all the factors of 2 in a non-field, right? Z5, the modulus is prime, so this is a field, and then we're going to do we'll do Z6 after this, so where it's not necessarily a field. All right. Well, Z5 is a field, and if you think back to factors of like real numbers or rational numbers, basically everything is a factor of everything else because you can divide. So for any A, which is non-zero, 2 we can write as A times A inverse times 2. So any A is a factor of 2 provided it's non-zero. So all non-zero elements are factors. And this is a common phenomenon in fields. Let's look at a slightly more interesting example. Let's find all factors of 2 bar in Z mod 6. All right. Well, in Z mod 6, 2 has the following. We can write 2 in the following ways. Well, we can write it as 2 times 1, but that's kind of like in one of the previous examples where it's a unit times times the unit inverse times 2. But the interesting factors are the ones that aren't associates, so not related by this unit thing. So 2 we can write, well, as 4 times 2, right? Because 4 times 2 is 8, and 8 is the same as 2 mod 6. In particular, the factors of 2 are itself and 4. Now this is very weird behavior because this is a non-trivial factoring of 2, right? Like there's neither of the terms are units. Anyway, so this is kind of an interesting factoring of 2. And it's very weird from what we know about factoring integers. And the idea is that in domains, factorization is a lot nicer than in a general ring. And so we're going to focus primarily on factorizations of elements in domains to avoid behavior like this.